Venus is Earth's nearest neighbor. It's closest to Earth in size and composition, yet something clearly went awry. Its atmosphere is almost entirely carbon dioxide. Surface temperatures are a scorching 460 degrees Celsius, hot enough to melt lead. Pressures are 90 bar, as crushing as being 1 kilometer deep in the ocean. Understanding how Venus's atmosphere turned into a runaway greenhouse, boiling away any oceans and baking the surface, could help astronomers studying other solar systems. They could distinguish truly Earth-like exoplanets from evil twins like Venus. Until recently, Venus's treacherous surface conditions made the idea of an extended stay on the planet a far-off dream. In the 1970s and 80s, the Soviet Union hurled mission after mission into the planet's inferno, but none survived more than a couple hours. Under soaring temperatures, silicon, the backbone of modern electronics, loses its semiconductor behavior. Transistors stop working. Now researchers are developing microchips made of silicon carbide, which can function at much higher temperatures. They have not been able to put billions of transistors on a single chip, as in conventional electronics, but even with hundreds of transistors, the chips rival the capabilities of computers from the early days of solar system exploration. To test the endurance of these chips, researchers used NASA's GEAR, the Glenn Extreme Environments Rig. GEAR is a pressurized chamber the size of a minivan and weighing in at 14 tons. It can simulate the temperatures and pressures of Venus's surface. It can also mix in 8 different gases to create a Venus-like atmosphere. Recently, researchers tested silicon carbide chips inside GEAR. They functioned well during a 60-day test, an ordeal that may have changed the course of Venus exploration. Rather than hiding electronics in heavy, refrigerated pressure vessels, researchers hope that by early next decade, NASA may be able to land simple, unprotected robots on Venus's surface. And instead of running for a few hours, the landers could last for months, giving us a glimpse of Venus's surface never before thought possible. One big question they could help with: is Venus geologically dead or alive? Many researchers think that some 500 million years ago, a catastrophic event covered the planet's surface in magma and wiped it clean, but that Venus has been pretty much dead ever since. But in recent years, measurements from orbit have detected spikes in volcanic gases, such as sulfur dioxide, and some volcanoes thought to be dormant have been found to be abnormally warm, signs that Venus might not be as inactive as we thought. There is, unfortunately, still a long way to go until we touch down on Venus's surface. But when we do, these resilient electronics will be crucial in allowing our robots to take the heat.